Hey everybody, it's Darren. Thanks for coming back to the NYPD project, the New Yorker Project Deluxe, and my 1954 Chrysler New Yorker. So we're stripping things down as we work on the Operation Break Free. The engine is soaking in the secret break loose juice. And in the meantime, we're cleaning and priming the pieces here. I think we're on day 6 of soaking the pots with, the ATF, the Marvel Mystery Oil PP Blaster. So we're in that process here to see if we can get that engine to break free. Not sure how well it's going to go, but we are giving it the old college try. So anyways, we spent some time to make the generator look presentable. Everything is kind of covered in 70 years of oil, grease, and grime. I figure as we peel back this onion layer by layer, we will clean and Craigslist restore each piece. So when the day comes to put it all back together, we have some fresh components to put on there. So the generator, as you see here, it shares a pulley with the power steering pump. And we got a quick look at the connection between the two pieces. Generators are large to begin with. Combined with the power steering pump, it's a very sizable unit, almost 20 inches in length. So as packaging became more important with the forward look cars coming out in 55 and the upcoming compact car segment, downsizing was important. This car is very analog. There's no electronics here. The generator is regulated purely by mechanical means. The AC current, inherent with all rotating EMF generation is single phase, converted to DC through the commutator. There are many videos out there that detail how a generator or alternator functions, made by folks much smarter than me that explain it very well, but I thought I'd highlight a couple of ways this car goes about doing the charging. Generators and alternators create current by moving a coil through a magnetic field. One big difference in an alternator is that it's the magnets that move. They're actually fixed in a generator. The magnets are electromagnets. The magnetic field created by energizing the field coils. The stronger the magnet, the more current is produced. So consequently, the output of the generation is controlled by raising or lowering the magnetic field through the current applied to those field coils. In a modern car, in the electronic age, diodes and transistors do that job. In the early days, such as with this car, it was done mechanically. This car does the regulation with the voltage regulator. That's the big black box on the firewall. The regulator does 3 functions. The first is the current cutoff. It's essentially a switch that prevents the battery from backflowing to the generator. The generator can actually work like a motor. It'll motor if you reverse the current flow. So no power from the generator, and the switch flips to keep the flow going just one direction towards the battery. So those sorts of things are done by diodes now. So the current regulator and voltage regulator work together in similar fashion. They're preset to trip at certain levels. The regulator, via a set of points, triggers flow to a field coil resistor to lower the strength of the magnet, which reduces the output. So you drop the current to the field coils. The field coils produce a smaller electromagnetic effect, and therefore it reduces the amount of current created by the battery and the voltage. So it happens at high frequency, essentially vibrating on and off rapidly to maintain a relatively constant current and voltage. The battery itself acts as a capacitor, smoothing out these pulses in the charging circuit. So generators had many moving parts and wearable parts, and the regulator was also mechanical with moving parts and many points of failure. Alternators greatly simplified the process with an exponential rise in reliability. It was Chrysler, the engineering company in 1960, that brought alternators into the mainstream, being the first to use them on a wide scale with the all-new Valiant. Diodes and transistors changed charging, allowing the much lighter and compact alternator to rise as the industry standard. Generators are heavy and also very large. Some might think that the manufacturers didn't care about weight in the 1950s and 60s. What with the trend toward larger, heavier cars with bigger and bigger engines and more comfort features. But factually, if they could take 40 to 50 pounds out of one component, they could add that weight back in elsewhere to make the car bigger or more luxurious without a subsequent weight or performance penalty. This car's power plant assembly was nearly half a ton, 1,000 pounds hanging out on the nose. Nearly every piece is cast iron. The thermostat housing, the timing cover, starter, generator, power steering pump, intake manifold, the distributor. Only the oil pan and valve covers, fan and pulleys are really parts that aren't cast iron. Another inherent problem with a generator versus an alternator is they charge very little at low RPM. Kind of unheard of these days, but sitting in stop and go traffic with the lights on, the wipers or heater, the battery could discharge faster than it was replenished. So thanks again, everyone, for watching. Every view is appreciated. If you feel so inclined, please drop a like, leave a comment. I read and respond to all of them. See you again real soon. Valve covers are coming off next, so subscribe, hit the notification bell. Peace. We'll see you next time. Okay, I've got the generator and the power steering pump off the car. I've spent few hours last night with the wire brush and the SuperClean degreasers, scraping the crud off of there. The power steering pump connects to the back of the generator. 3 bolts that bolts on back there like that. There's kind of a keyed chuck here that mates with the back of the generator. So as the generator turns, the power steering pump does its thing here as well. So that's kind of neat. One pulley runs both. And they are heavy. It's got some meat to it. It is solid cast iron case all around it. This is the cover band. It goes around the back here. I painted it silver. It's deteriorated. There's a lot of pinholes in it. I'm scared to even bend it. It might just break, so I'm kind of trying to keeping it in the original shape as it came off. It's a very thin tin band, so it doesn't have a whole lot of life left in it, so I'm going to try to be gentle with that as much as we can. I'm going to paint the body of the generator black. Of course, I'll cover up the terminal points on here, and I'll cover up this exposed area where the band would go. I'm going to paint the bottom of the power steering pump black as well, and then the reservoir. Originally it was black, I'm pretty sure, but I'm going to do that silver. Paint I'm using, the silver, it's a duplicolor engine enamel. I don't know what color it is, but what the code is, but I did the thermostat housing with it. That's the color there. It's a nice silver. It's pretty close, I think, to what the factory color would have been. I did the generator band in the same color, and I'll do the top of the power steering pump in this. For the black on the generator, black of the pump here, I've got Tremclad Professional High Performance Rust Enamel. It's a high gloss black. Should go over this pretty well and stick pretty good. It's protection. This engine enamel says it's good to 500 degrees Fahrenheit, so I'm okay there. And I've got a gray build primer. I think I'm going to prime the pump before I paint it silver. I'm going to paint that part. I'm going to prime it first. This cast iron stuff, I think this will cover okay on its own, but this is a different type of metal, and I'm going to prime it first. Spray it all down with brake clean before I do that. Okay, so that's what we're gonna do. The engine's been soaking, so it's been 5 days now with the secret sauce down the cylinders. So I wanted to get this stuff down and the pulleys done and whatnot done in this time, window when I can't be working really on the engine itself. So I have the generator back on the bench here, painted. I'm gonna put the cover band back on. This has a bunch of little pinholes in it. that this is deteriorating, and I'm scared to even bend it, that it might just break. So I'm trying to be very gentle with it. I did paint it with the silver engine enamel. All right. Okay, so the band is reattached.